want to start this lesson off with a reminder of a scatter plot. And it says right here, to make a scatter plot, you simply just plot the ordered pairs on the graph. The big thing that I have underlined and made bold, you do not connect those ordered pairs. So I don't have an example of making a scatter plot. So if you need another example or you need a refresher, you need to go back to linear regressions in module 1 and see how we made a scatter plot, but it's just simply plotting your ordered pairs. But you don't connect the ordered pairs. It is just those random points, and you don't even draw in a line of best fit. Okay, so just plot them. Now, I included again how to make a scatter plot in your calculator, but really and truly, you don't need to do that. What we need this for is to enter in our data into the calculator so that we can make a regression here. When you're doing it by hand, you're just plotting the ordered pairs. When you're doing it in MyMathLab, you're seeing which scatter plot, multiple choice, has the ordered pairs correctly, right? So we'll use this more to just enter in our data rather than making a scatter plot. Here's our instructions on how to make a quadratic regression, and it's almost identical to our linear regression, except now when we go to stat and go over to calc, now I need number 5 right here. So we were going with lin regression for linear regression. Now we need a quad reg for a quadratic regression. So now we're going to number 5 instead of number 4, but the process is the exact same. I went over in linear regression what this optional steps do, but we're always going to be using our rounded regression, not the exact. So I'm not going to be using these optionals, but if you want to see what those optional features are, again, go back to module 1 over linear regressions to see what this does here. So let's just go ahead in the same video, go over example 1 here. It says, find the quadratic function that best that best fits f of x defined by the table below. Round to the nearest hundredth as needed. So hundredth is 2 decimal places. And let's put this into our calculator. My x is my L1, my list 1, and my f of x, or my y, is my L2. So following these instructions here, I'm first going to go to stat, which is under delete, which is under zoom. So stat. We're going to hit enter because I'm already right here on edit. So it says here, if needed, we need to clear the list by arrowing up to highlight the list, press clear, then enter. So if I want to clear list 2, I'm going to highlight L2. I'm going to hit clear, not delete. I'm going to hit clear and then hit enter down here. And when I hit enter, it clears that whole list for me. I'm going to do the same thing to my list 1. I'm going to arrow over, highlight it, hit clear, and then hit enter, and it takes all of that away. So now I'm going to enter my data into L1 and L2. So here is my data. So L1 is 0, 2, 4, 6. And then we get negative 1.62 and keep going. Okay. Now, before we go, and I probably just need to honestly add this as a step up here, but before you get out of this list, just check your data. It takes hardly any time, and it makes a huge difference when you get something wrong. Do not get the problem wrong because you did not take the time to check your numbers. So I've got 0, 2, 4, 6, 0, 2, 4, 6, like it. And then I'm going to check my L2 numbers as well. Okay, so I like my numbers. So now I'm going to go over here to y equals, and I need to clear any equations. So I'm going to clear that out, and I need to turn my plot 1 on. So my plot 1 isn't on right now because it's not highlighted or boldened. So I'm going to come over here, hit enter, and now when I get off of it, it should stay lit up or highlighted in some way. Okay, and we have a note here. We need to turn that plot 1 back off when we're not doing regressions or scatter plots. Okay, so if I did zoom stat, we could get our scatter plot, but it doesn't ask anything about a scatter plot here, so I'm not going to go over that right now. So now I'm going to go right back in here to stat. I'm going to arrow over to calc, and I want number 5. So you either need to arrow down or just punch in 5. I'm not going to do any of these optional things. I'm going to go straight down to calculate. And here we are. So I need to round to 2 decimal places to the nearest hundredth, and all of these only have 2 decimal places. So that's nice. So my A equals 3.08. My B is 3.94. And my C is negative 1.62. I'm also going to go ahead and put this R squared here. We talked about R squared last lesson on regressions. That R or R squared, the closer it is to 1 or negative 1, the more accurate this is. So because this hits 1 right here, this means that this is a perfect fit. So notice they tell me what A, B, and C is. Let me make a better equal sign here. That's bothering me. They tell you what A, B, and C equals, and they tell you exactly what equation you're using. We are using y equals ax squared plus bx plus c, and that should be familiar. We are doing a quadratic function. That is my exact quadratic function that we've been using. So now plug in your A, B, and C here. So I have y equals 3.08x squared plus 3.94x, and then plus c. If my c is negative, that will be a minus 1.62. So there is my quadratic regression. Now, you can stop right there. That's all it asks for. But to kind of show you here, if I went in here to my y equals and I plugged that in, and I did my zoom 9, you can see here it hit all of those points perfectly because it is a perfect fit right here. So nothing is off that line. It connects everything just the way it should.